Welcome to this presentation of Book 2, Module 7, covering the implementation of DHCP version 4. We will configure DHCP4 on a small network using Packet Tracer, and we will examine how DHCP operates in a small to medium-sized network. So let's begin. DHCP, which stands for Dynamic Host Configuration Protocol, assigns IP addresses and network configuration information dynamically for hosts on a network. DHCP can be configured on a dedicated server on the network, or it can be configured using a Cisco router. Regardless of whether a server or a router is used, DHCP is used to assign or lease an IP address from a pool of addresses for a period of time defined by the server. In other words, a host is not assigned an IP address indefinitely. It is eventually returned to the IP pool. DHCP works in a client-server mode. The client connects to the network with the leased IP addresses and periodically contacts the server to extend the lease. The lease mechanism ensures that when a machine is powered off or is no longer on the network, for instance, if you connected with a cell phone or a laptop, that IP address will be returned to the pool for other hosts to use. Take a look at this diagram. You should expect to be tested on the 4-step process to obtain a lease. It starts with a DHCP discover broadcast from the client requesting an IP address. The server will respond with a DHCP offer offering an address. The client will respond with a DHCP request accepting the IP address, and then the server will finally send out a DHCP acknowledgement acknowledging that the IP address has been leased. Like I said, this is a process you probably will want to familiarize yourself with, not only for the module exam, but possibly for the certification exam as well. Right? And the renew a lease is just the last 2 steps of the previous example. The client sends out a DHCP request, and the DHCP server responds with a DHCP acknowledgement. And that's basically how DHCP works. DHCP definitely has advantages. The larger a network is, the more difficult it becomes to manage using static IP addresses. Let's take a look at a packet tracer example here. We're going to set up this network using DHCP. It's a very simple network, one router, one switch. There is another router in the cluster, which represents the ISP. We're going to configure DHCP server on gigabit 01 to assign addresses out of this network to these hosts. And we're also going to set up gigabit 00 to be a DHCP client so that it will be assigned an IP address by the ISP. This is not an uncommon setup in a small office, home office type network. As you can see, if we open up one of these hosts, they are set up to be dynamically assigned an IP address using DHCP. As you'll see, the DHCP is assigning itself a 169.254 address. That's a link local address or an APIPA address. And that is because DHCP is not set up on this router yet. So it is assigning itself that number. So let's go ahead and fix that. So the first thing we want to do is exclude some of the IP addresses from the DHCP pool. And this is to basically allow us a certain number of static IP addresses that we can assign to things, servers, things like that. we're just going to exclude the first 10 IP addresses out of this range. And we'll name and define the DHCP pool. Call it LAN 1. The network is 192.168.1.0/24. We are going to set up this interface as .1 out of this network. So that will be the default gateway. So we'll define the default gateway or the default router as that IP address. And we'll put in a DNS server. We'll just use one of Google's DNS servers. And we'll also assign it a domain name, just to show you how that works. So let's set up the interface. Your gigabit 01. Fast forward in time a little bit. And as you can see, now these hosts are being assigned an IP address out of this network. And it's also assigning its default gateway as that we defined. It's also assigning the DNS server. And we should be able to ping the gateway at this point. Garbage in there from before. Try that again. And it's successful. We still can't get out to the network because we have not configured this interface, and we need to configure this for DHCP to be assigned an IP address dynamically by the Internet Service Provider's router or DHCP server. Let's go ahead and fix that real quick. That's interface gigabit 00. And just add IP address DHCP, and that will set it up as a client. And okay, it's already been assigned an IP address. We hover this. Hover over this. You'll see that gigabit 00 has been assigned 201.17.10.10 by this router. And that's how DHCP works. We just do one final test just to make sure that it goes through. Oh, there it is, successful. So you can see it's working end-to-end now. Thank you for joining us for this presentation. You have a great day.